Hello everyone. This week I'm focusing on ionic compounds. Ionic compounds naming, formula writing, and how ionic compounds are formed from cations and the anions. Ionic compounds are formed by transfer of electrons from metal to non-metal. The opposite charge ions, we call it positive charge cation and negative charge anion. They electrostatically attract to form ionic bond. You can see in this example sodium. Sodium is a metal. The configuration is 1s2, 2s2, 2p6, 3s1. Fluorine. Fluorine is a non-metal. Configuration is 1s2, 2s2, 2p5. So metal and the non-metal. Metal 3s1 electron transfer to 2p5 orbital of the fluorine. Then it becomes sodium plus cation. The reason is 3s1 electron is now transferred to fluorine. 1 electron less indicated by 1 plus charge. This is we call a cation or positive charge ion. And fluorine 2p5 become 2p6. 1 electron extracted to fluorine. Then fluorine become fluoride anion F-1. Now you can see cation and the anion. They are oppositely charged, plus and the minus. They are electrostatically attracted to form ionic compound sodium fluoride. This is the basic theory behind how ionic compounds are formed between metals and the non-metals. So as I explained in the previous slide, ionic compounds formed between metals and the non-metals. You will know group 1, group 2 and group 3 except boron. The others are metals. Non-metals group 5, 6, 7. Most of them are non-metals. So when metals combine with non-metals, they form ionic compounds. Magnesium oxide, one ionic compound. Magnesium is a metal, oxygen non-metal. Potassium fluoride, ionic compound, potassium metal, fluorine non-metal. Zinc oxide. Zinc is a transition metal and oxygen is a non-metal. So transition metal or main group metal when combined with non-metals form ionic compounds. Only the non-metal combination or metalloid non-metal combination form covalent compounds. Let's talk about what are the charges formed by each group, cations and the anions. First, let's focus on main group elements, group 1a to 8a. They have fixed charges. Fixed charges means only one charge species, exception for tin and lead. All the other main group elements form fixed charges, only one charge species. Cations. Metals form cations. Metals are less favored for electrons. They like to lose electron. So group 1a metals, they like to lose 1 electron to form plus 1 charge. So if you go from top to bottom in group 1a in the periodic table, lithium, sodium, potassium, rubidium, cesium, they all form plus 1 charge. Lithium plus 1, potassium plus 1, cesium plus 1, plus 1 cations. Group 2a. Group 2a elements form plus 2 charge, losing 2 electrons. Group 3a metals form plus 3 by losing 3 electrons, 3 outer shell electrons. Now you can see group 1, group 2, group 3. They are forming plus 1, plus 2, plus 3. The plus charge is equal to the group number. Two exceptions, tin and lead. Tin and lead are in main group elements, but tin and lead form two charge species, plus 2 and plus 4. Tin plus 2, tin plus 4. Lead plus 2, lead plus 4. All the other main group have one charge. Now what are the charge on the anions? You can use this formula to calculate the anion charge. 8 minus group number. So let's apply for group 5. 8 minus 5 is 3. So 3 minus. In group 5, nitrogen, phosphorus, arsenic group, all the anions charge should be minus 3. We call nitride, phosphide, arsenide. Group 6, 8 minus 6, 2. Then 2 minus charge for all group 6 non-metals. Oxygen, sulfur, selenium, oxide, sulfide, selenite, IDE ending. Group 7. 8 minus 7 is 1. So all halogens or group 7A nonmetals form minus 1 charge: fluoride, bromide and chloride. Now last slide we discussed what are the charges of the metals and the nonmetals of main group elements form. They all are monoatomic ions. Monoatomic means one atom containing ions. You can see in this table everything summarized for cations and the anions. Main group is group 1A to 8A, but group 8A are not forming any ions. They are inert or noble gases. So group 1A, 2A, 3A except boron, they are metals, form plus charge equal to the group numbers. And group 5A, 6A, 7A non-metals. 8 minus group number is equal to the charge on the ion. They are forming anions or negative charge ions. Now let's talk about how we can name metal cations and the anions. Metal cations. Name is easy because you don't need to use a different name. The name of the cation same as the element name, no change. For example, sodium metal and sodium plus cation, the same name: sodium, calcium, cesium, aluminum. Non-metals. Non-metals ending a suffix we need to replace with IDE, ide ending. Bromine become bromide, chlorine become chloride, fluorine INE replaced with IDE, fluoride, hydride, iodide, nitride, oxide, sulfide. How cations with variable charges are named? The cations with variable charges formed by transition metals. Transition metal cations most of the time more than one cation species. For example, iron Fe form +2 and +3. Copper Cu form +1 and +2. More than one cation. So when we have more than one cation, how we can differentiate both cations? We use two different methods to name the cations. One is systematic naming, the other one is common naming. In systematic naming, use Roman numerals equivalent to the charge on the ion. In the common naming system, we use two suffixes, OUS, S suffix, and IC suffixes. You can see in this table some of the ions given here. Copper form +1 and +2, iron form +2 and +3, tin form +2 and +4, lead +2 and +4. Now here tin and lead are not transition metals, however these two are the exceptions from the main group cations. All the other main group have fixed charges except tin and lead. So second column you can see the systematic name, how we can use this method to name these variable charge cations. The only thing is write the metal name and then Roman numeral equal to the charge we can write inside the parentheses. So copper +1 we can name as copper 1. Copper 2 plus we can name copper 2. Fe2 plus, this is iron, iron 2, iron 3. Tin 2, tin 4. What is the common name? Common name is not the element name, so you need to practice common names. Copper +1 we use adding OUS suffix, cuprous. Cu2 plus we can name adding IC suffix, cupric. So here you can see a pattern +1 +2. The smaller charge always we name adding OUS suffix. The larger charge we need to add IC suffix. So you can say Fe2 plus and 3 plus, the same pattern, 2 plus OUS suffix ferrous and 3 plus IC suffix ferric. Tin 2 plus stannous and tin 4 plus stannic. Lead 2 plus plumbous and lead 4 plus plumbic. So you can use a systematic or common, either one according to your convenience. What are the polyatomic ions? Poly means many atoms containing ions. This table summarizes most of the polyatomic ions you need in 10 Chem classes. You can see poly means many atoms in these ions. For example, Cn-, carbon and nitrogen, charge is 1-. Carbonate is CO3, charge is 2-. It contains 1 carbon atom and 3 oxygen atoms. This is one group, one unit. For this unit, charge is 2-. Then 2- is common to both carbon and oxygen. Let's talk about oxalate. Oxalate containing 2 carbons and 4 oxygen. This is one whole unit. For this unit, charge is 2-. The oxoanions, or we call oxygen containing anions. Oxygen containing anions, in the previous polyatomic table, there is a pattern of naming adding ate and ite suffixes. Nitrogen. Nitrogen is a nonmetal, so nitrogen form oxoanions, 2 different types, NO3- and NO2-. Charge is same, the only difference is number of oxygen, 3 oxygens, 2 oxygens. Sulfur. Sulfur is another nonmetal. It forms oxoanion SO4-2- and SO3-2-. Charge is same, only difference again number of oxygen atoms. Phosphate. Phosphate form PO4-3-. This is PO3-3-. Again number of oxygen different. Now you can see fewer number of oxygen atoms containing ion we name adding ite suffix. ITE suffix. So nitrite, sulfite, phosphite. Large number of oxygen containing ion we name adding ate suffix. Nitrate, sulfate and phosphate. So always ate suffix is going with large number of oxygen containing ion and fewer number of oxygen containing ion with ite suffix. Next, let's see how we can write ionic compound formulas. Formula writing using cations and the anions. Here there are 2 types of anions we discussed. Monoatomic anions like chloride, bromide, iodide. Monoatomic means only single atom containing anions. And then we discussed polyatomic anions. Polyatomic means many atoms containing anions. The method is same, the only difference is one single atom and many atoms containing in polyatomic ions. The question is, what is the ionic compound formed between calcium 2+ cation and phosphate anion? You can see calcium 2+ is main group cation, phosphate is polyatomic anion. The method is magnitude of the charges switch on the ions. So what is the magnitude of the charge on calcium? 2, number 2. It's not the plus or minus sign, only the magnitude of the charge. Calcium 2 and phosphate 3. So we need to switch the magnitude of the charges. 2 goes with phosphate, that means 2 phosphate groups we need. 3 goes with calcium, that is 3 calcium ions in the compound. So you can switch magnitudes. Calcium 2+ means 2 switch to phosphate. Phosphate 3- means 3 goes to calcium. So this is the ionic compound formula. Calcium 3, phosphate 2. 3 calcium ions and 2 phosphate ions in this calcium phosphate ionic compound. Why we need to switch this magnitude of the charges? To get the zero charge ionic compounds, we need to combine the proper number of cations and anions. Now let's check the compound we form. Sum of the charges. Calcium charge is +2. So we combine 3 calcium ions. So +2 times 3 plus One phosphate group charge is 3 minus. 3 minus times 2 phosphate groups. If we combine this, add all these numbers, the charge should be 0. Always you need to make a 0 overall charge ionic compound combining the proper number of cations and the anions. The short method is magnitude of the charges switch each other. I hope now you will understand how ionic compounds are formed, how ionic compounds are named, and what are the polyatomic cations and the anions, and finally how we can write ionic compounds formula. So you can see each of these topics I have explained in separate videos in my YouTube channel. So if you want to go and find it, please go and check out the separate videos. Thank you all for watching.